Okay, this is the intro lesson to solving exponential equations. And we need to solve for the variable, right? But all the variables are in the exponents. So our goal is that if the bases are the same, we can then forget about the bases and just take the exponents and set them equal to each other and solve. Pretty easy. Divide by 2, n is 4. Great. Let's look at number 2. The bases are the same, so we can forget about the bases, and we would set the exponents equal to each other, and we would solve. So how do we do this? We have to bring the n's together. So subtract 2n. 2n plus 5 equals 1. Get the 5 out of there. 2n equals negative 4. And divide by 2. Make that a little smaller. So n equals negative 2. Okay? And the third one. Bases are the same, so we're good to go. I'm going to cross those out and say 2x, oops, not an n, plus 1 equals 1 minus 2x. Bring your x's together. 4x plus 1 equals 1. Subtract 1. 4x equals 0. Divide by 4, you get x is 0. Okay? Now, the red problems are for you to do for homework. So I did the 3 above, you do the 3 below. They're pretty identical to the ones I just did. Now I'm going to do, if you notice, 2 sets of rows, right? 7 through 12, and then you're going to just do 13, 14, 15. But notice our bases are no longer the same. So how do we do this? So what we're going to do is make the bases the same. And we're going to think, I need to get a 2 and the 4 to be the same base. Well, I'm thinking I can leave 2 as a 2, but isn't 4 also 2 squared? So once I make them the same base, right, now they're both 2's, I can cross them out, and I set the exponents equal to each other. X is 2. Let's do that again. We have a 3 and a 27. It's like, all right, I think I'm going to leave the 3 as it is, 3 to the 2a. But 27 is really 3 to the 3rd. So you kind of play around in your calculator, and you're like, can I make the 27 like the 3 base? And you're like, okay, 3 to the 1 is 3. 3 to the 2, 3 to the 3, and we get that. So now I have the bases the same, and I'm going to cross them out, and 2a equals 3. Divide by 2, and a is 3/2, or you can write 1.5. Either way is acceptable. Number 9. Bases are not the same, right? So we're thinking, I kind of try to start with my small one. Can I leave it as a 5? And can I make the 25 as a 5? And I sure can. 5 to the negative 2n. 25 is really 5 squared. Now I have my bases the same. So now I just take negative 2n equals 2. Divide by negative 2, n is negative 1. Okay, let's do 3 more, and you're going to do the bottom 3 for homework. All right, I have a 5 and a 125. Let's think. I'm going to try to leave the 5 as is. And then 125, let's think. Can I make that as 5 squared? No good. 5 cubed? Yeah, 5 cubed is 125. So use your calculator to help you out. And now the bases are the same, which means we can cross them out. Negative 3x plus 7 equals 3. Get the 3 or the 7 out of there. Negative 3x equals negative 4. You can certainly have decimals and fractions. X is 4/3 or 1 1/3 or 1.33. Either way is fine. 2 more to do. Ooh, a 25 and a 125. I just did a 125 as a 5. Could I change both of them? Probably. So 25 is 5 squared, and 125 is 5 cubed, right? But remember, we still have this attached to the 25. So you need to put that in. You need to keep that, and we will multiply. Okay, so you have to bring that with. So now I have the bases the same. And the left side is going to be negative 4x plus 8, because I distributed that out, equals 3. Subtract 8. Negative 4x equals negative 5. X is 5/4, or 1.25. Either one is fine. So you might have to change both of them. You'll kind of know. You'll think, can I get a 25 to be 125? And you're sitting there trying, and you're like, 5 squared is already 625. So that doesn't make sense. Last one. And we're going to do this again on Tuesday, but 32 and 4. Can I make 4 become a 32? Let's see. 4 squared, no good. 4 cubed. Oh, I'm already at 64. I'm already bigger than that. So I can't even make a 4 become a 32. What if I make them both 2s? Well, I know this. I know that 4 is 2 squared. Isn't 2 to the 5th 32? So I can do this. And then I just have to keep my original exponents. And now I can do this. Bases are the same. Now I have negative 10n, negative 4n minus 2, right? I distributed. Add 4n. Negative 6n equals negative 2. Divide, I get 1/3, or I get 0.33. Either way. You are doing 6 problems. The first 3, number 4, 5, and 6, have bases that are the same. And 13, 14, 15, they are not the same. Take care.